My name is Martin Haas. I'm an architect out of Stuttgart, Germany. First slide is my office. I'm co-founder of this studio 2050. We are roughly 30 architects working internationally. And sustainability is one of the driving forces of our work. I'm also one of the founder of the German Green Building Council. I'm in the board since 10 years now. And we believe as architects that sustainability is just a very weak term for a radical change in society. So it's much more than what we think it is. It's not only about energy saving, it's about democracy for the future. So how can we not steal the future the same kind of properties and basics as we have them today? And with all of that, it comes together that the society itself has changed a lot. So I'm quite very sure that if historians will look back on this period of time, they will realize it's a change of an era. So one era come to its end and a new one is going to start. So many massive changes has gone on. We grow older. Health is becoming the biggest good, the biggest quality of luxury. The typical biography of the former period has changed. Youth is transmitting into old age situations. It's not only dealing with nature and climate change, I think it's dealing with a complete change of the way we have lived so far. And that is, in my understanding, a big challenge for us as architects. And our response is a bit weak, I would say. I mean, what we do is we still think conventional and probably rethink the way of energy production or energy consumption or dealing with insulation. But maybe we should ask ourselves, is the form of house still the same one as it should be requested for these future generations? Or shall we rethink completely the basics of the way we build and construct? And I believe, yes, we should. We should ask ourselves these questions, and we should most likely come to different answers. And that is, for me, the driving force for our studio, that we ask ourselves on every work, on every project we do, what might be the expectations of the next generations to come. And one of the biggest challenges we face is certainly space. I mean, the surface of Earth is completely restricted. We know 8 or 9 billion people on planet Earth. Means roughly that we have 2,000 square meters for everything per person. So everything means that on these 2,000 square meters, we are not living only, but 2,000 square meters are in need for clothing, for energy, for mobility, for construction, for all the square meters. Earth is our only production resource, and therefore space is a very important aspect in architecture. What does that mean? It means, for example, that's a Times Square, New York, that time and the time span when the building is in use becomes very important because, for example, I had a discussion about the sustainability aspects of Stuttgart in comparison to New York with the mayor of here in Stuttgart. And we realized that New York is much more sustainable when it comes to sustainability or energy consumption per person and not per square meter. What we do here in Germany, I don't know if you do the same in Norway, that we measure energy consumption per square meter. We should measure it per person, and we should therefore develop only constructions which are massively in use, so that the effort of construct something is a value in itself, that quality matters, not quantity. An example, so I can do here a passive house structures, 15 kilowatts energy consumption per square meter and year, and I consider it as a good building. But if nobody is using it, or only few people is using it, then the effort didn't make any changes. And the effectiveness of my effort was quite little. Therefore, always consider I believe it's important when we consider construction developments, that we want to have maximum user groups, that the building should be 25 hours per day, 7 days a week in use, that it made sense for a lot of people that this building is there. This gives us a bit an image of the huge difference between efficiency and effectiveness. So this train is absolutely it does have a huge of an effect to the people. The transportation per person, energy consumption wise, is most likely much better than these high-tech trains we have here in Germany, where only, 5% of these people are transported. Nobody wants to be transported like this, but it frames us a bit the view into that we have to deal in architecture not only for the shells, we really have to deal with the users. We have to deal with the quality of the space. We have to deal with timing, and that this effort of building does have an impact. I give you an example. What do I think is needed? That was a commission. We were asked here in Stuttgart to refurbish, to renovate a former industrial area in the close proximity of downtown Stuttgart. So a classical 70s, 80s development. Some fabric situations, some offices, and now the request of the city is that the facilities went out of the city, and the city requested back for residential units. What we did we measured the embedded energy in these structures. We realized the structures themselves in terms of development of windows, openings, the potential of daylight and ventilation issues. The embedded energy of the construction itself is 40% in life cycle expectations of a structure. So it would be very wise to keep maximum of the existing structure and refurbish and reuse it differently, and then gain also some strategies for the untapped resources of roofs, of the soil, of the insulation materials, of the embedded energy consumption, energy production. And we overframed and overdone the existing houses with extra structures, which are then based in the strategy of renewable materials, wood constructions, loam, earth constructions, a lot of greenery to trigger the microclimatic aspects of the situation, and also to have a kind of a resilient community, completely self-sufficient when it comes to energy production and energy consumption, and to use every square meter for people. So what we realized in this commission is that technically we have all the tools which are needed to develop a zero carbon neutral urban strategy. The most difficult things is that we have to treat the way of living differently. So it's not, sorry for that this chart is in German, but most likely you can see what I'm talking about, that the first fields, energy, water, material, I think we are on a good track. I think we have some strategies. We know how we can reduce the carbon footprint tremendously. So we have more efficiency knowledge when it comes to energy consumption, energy production, PV cells in cities, wind energy. So I think the technology is already there. We know that we have to deal with water differently. So we have to reuse every centimeter of water. Water will be one of the biggest resource challenges in the future locally. When it comes to material, we will speak more about loam these days. we have proper knowledge. We know that mobility is something we have to deal with. You are very fast forward in Norway with electrified mobility. So we know all these aspects. What we realized in this commission is that, for example, 15 square meter of a very nicely sun-lit roof area in this construction would be a perfect place for tomato production. But then these tomatoes, who are owning them? Is that then in the possession of the person living in that structure? Because it would be very wise if these tomatoes would be then subdealed to all of the community. So the sharing society is something we have to really talk about. And that's coming back to my first chart. That is the new area we are dealing with. When we really talk about a completely sustainable future, we have to rethink the goods of ownership, responsibilities, insurances. A lot of these aspects have to talk about. Technically, we as architects know what to do, but the sharing community needs to have a change in society. That was one of the outcomes of this commission. I show you also, when it comes to commissions, how we deal this resource base differently. So we were challenged by a commission and competition for Guggenheim in Helsinki. You may have heard about this competition, 1,700 entries. We were lucky to be one of the finalists. And I want to show you how we approached then an architectural commission. So the site, very nicely located in the harbor area, the harbor front, a perfect site for a museum, I would say, or you would say. But then on the other hand, why should we consume all of the area alongside this harbor for only one user group, for the museum goers? We thought, no, first of all, let's check what extra quality we can place in that building beside just being a museum between 9 a.m. in the morning and 5 p.m. in the afternoon. We took a careful look what kind of events, what kind of public events happen in Helsinki, and where we can add on some quality throughout the year. So that event calendar we developed together with some urban consultancies. We worked together with Gale Architects in Copenhagen. You may be aware of this firm. And we wanted to generate extra value besides being only a museum. And then we realized it would be perfect to have a public space where you can celebrate the festival of coming back of the sun in the spring period, because like all the northern cities, the lack of sunlight is a big issue, and celebration of light, having outdoor areas which are very well protected against wind conditions, nicely sun-inlit, it's a quality. And to have a public space which is not limited by museums goers, that would be something where we could see extra value. And the other thing was that we said we shrink the footprint of the building to a minimum. We only consume the green area is the site which had been possible to be in use. We said, no, we only need to have a bit of a footprint to open up for future developments, the area, to save the resource of space and to generate a very compact museum, which is public accessible and certainly done with other materials. But for me, the strategy for a complete sustainable structure is not that you start with materials, you start with the resource base, you limit yourself, you do a footprint which is as much shrinking as possible, and then you deal with materiality. So the 5 wood towers share a public space, shelter it against the strong winds. The 5 wood towers are placed in a way like a Stonehenge, Lighthenge, in order to have the possibility of sun penetrations on the 21st of March and the 21st of September to celebrate the Festival of Light in the public space between the towers. And we thought about what else could be embedded, what might people look for when they enter the site. And so we generate places for a viewing platform on the rooftop, the garden facilities next to the tower, where the sheltered outdoor area against strong winds. So we looked for possibilities to have a 24-hour environment and quality for this museum. I don't want to show you the interior. That's a bit too much for today. I just want to give you an idea how we approach any of our commissions. And when this quality, or when this the question of space is positively answered, then it comes to materiality. And I mean, you are very fast forward when it comes to wood constructions. We are in Germany now running up a bit better, so we have a couple of wood constructions coming ahead. And when it comes to natural materials, you know, the quality of natural materials is not only that we found them, they are regrowing, and they don't make any waste. And when we deconstruct something, we can reuse them. There's another quite absolutely important aspect. This is the emotional linkage to the users. I mean, people like these materials. They like loam, they like wood, because it reminds them that we are part of the nature. And this emotional link to architecture is such an important aspect, that architecture is kept for a long period, that architecture is durable. Because one of the second strategy measurements for good sustainability is that when you build, you should build for as long as possible. All of our life cycle analysis shows us that, especially when energy consumption is more efficient, that the embedded energy of the construction, this value, is unbeatable high in comparison to the user energy. And it makes only sense if the construction is in use more than 25 years. It should be 50 years, should be 75 years. And for example, a classical office structure in Europe does have a durability period of 25 years. So it makes sense to build for a long period. And to have an emotional link helps that people have an emotional, they like the buildings, that they use it more often. They fight for them, that they are still with it's a part of the cultural heritage. That was one of the biggest disadvantages of modern architecture, that a lot of modern architecture were not beloved by people. They were beloved by architects and academically well-treated people, well-trained people. But the mass viewers, they didn't have an emotional link. So, and therefore, it was easy to throw them away, and it didn't become part of the cultural heritage. So that is also a very important aspect, and this emotional link. And it gives us an extra, how shall I say, an extra argument when we talk to clients. And for example, loam, when we talk to clients and they are afraid of erosion and durability, and then we can easily show them with the buildings which are already done in this way, how much linkage these buildings gave the people, and how much the people liked the qualities of these structures through these emotional aspects. So, a lot of pre-speech for materials. I mean, I hope that a lot of architects listening to this lecture are aware about embedded energy and natural materials and the advantages. So I don't want to steal a lot of time re-argumenting these criteria, these classical criteria, why it makes sense to use as much as possible what you find in nature. But again, I mean, it doesn't rely you, or it doesn't relieve from a proper in-front strategy how you build. So I talked a lot about the space, but then it comes to orientation, then it comes to classical approach to architecture to build, first of all, as little as possible. And that is this approach of new simplicity. We talk a lot about in the last couple of 3 or 4 years, that every extra element you build is a resource. So the next strategy, no space, is and natural materials, is just build as little as possible. And really think about the orientation. Where does an opening make sense? How much light you really need for this kind of usage? Because here in Germany, I mean, and in Norway might be the same situation or almost close, 85% of a year, you don't need any heating or cooling in the building. When the building is properly done, when the ratio between openings and closed areas is properly considered, then there's no need of any heat or cooling. So simplicity means just work with a microclimatic situation best. And then you have 85% of a year, don't any issue with energy consumption at all. And only for the last 10-15% of a year's period, when it comes to an office building, for example, where energy, where comfort demands are in lack of natural resources, then you have to deal with high-tech elements. The high-tech elements, but then needs to be as an add-on element. Never embed high-tech in the structure of a building, because high-tech means it's outdated in the moment when the building is inaugurated. So it's like buying yourself an iPhone. You go out of a shop and your iPhone is outdated, and don't think that building technology is different. It's the same. So high-tech, if it is needed in terms of lighting, cooling and heating, never embed that in the structure of a building. Put it attached, that you can still see it, that you can redo it, that the effort of redoing is little, and that the building itself works without technology. That is when we work here with our architects. We think, first show me an approach, a design solution, how we can provide a building without any technology at all. And it helps to think differently. We too often think from the very beginning that there is technology, that there is heating, that there is cooling. Get rid of this thinking, and it shows you different solutions. I want to show you what we did here. And now we come to loam and earth as a material. We were commissioned to develop a zero carbon building in the center of Hamburg for the Hafen City offices. So certainly what we did first, after careful site survey, we developed the concept of a wood construction with a certain grid. And we had to deal not with an optimized orientation issue, because the site itself, through the given urban situation, were a bit critical. So we developed different aspects for different facade elements. We said in the north area, we did a survey where we realized that the wind speeds are still okay. The street itself is quite protected through the dense urban environment against strong, heavy rains coming from the eastern area. So we said, okay, in the northern area, we could really do a facade, a monolithic earth facade. The earth is a perfect situation. I mean, we find it everywhere. We can do it locally. We can produce this facade on site. What we realized in our building so far, that with the new aspects of better materials, higher efficient technology, transport is getting more and more important. The embedded energy costs, or CO2 or carbon footprint of transport, is now much more than 10 to 15% of the embedded energy in the materials. So it makes sense that you use what you find locally as much as possible. So, and we had some areas close by where we could find loam. So we said, okay, it's unused there in Hamburg, but we do it, we try it, we do a loam facade, rammed earth facade in the north area. On the south side, we have solar cells, vertical solar cells for energy production. We have a wood construction as the basic grid of everything. The wood construction is not a glued one, so it's separable. We don't use any adhesives, and we have Corbock for insulation. We have a casein finish for the roofing, and everything is easily to mantle and to dismantle. And that is our strategy, because when it comes to the sustainability goals, and when we really talk about climate neutral buildings, and you see in the first bar the embedded energies for the production of the materials, we had to deal with some concrete in the foundations and in the first levels below grade, and we could easily go against this embedded carbon with a complete wood construction for the 5 levels above. We calculated everything on a 25 years perspective, but these bars, to be positively in the complete life cycle, were quite only doable with a quite little amount for transportation in the production process. So we had a radius of maximum 120 kilometers in calculation to bring clay and rammed earth and materials such as timber to the site. So transportation is important. That was also one of the learning exercises of a building we completed last year. That was a new headquarters for Alnatura, an organic food company here in Germany. And we did with them a survey for sites half a year to figure out what might be the best place for this new headquarters in the great city area of Frankfurt or Darmstadt. And we finally ended with a former military camp area in the southern suburbs of Darmstadt, close by this forest. And because we found a couple of advantages. We said, first, headquarter means people 500, 600 needs to go there on a daily basis. So we have to have a good mobility strategy. We need to have public transportation in close proximity. Next was that, and that was possible here. By reusing an existing site, we have lots of embedded energy where we can probably deal with. And this former military camp, the sealed paved structures were parking places for tanks. So we can use the sealed areas already for our parking lots if anything are needed. We are in close proximity of a forest on the west side of the city. The forest is a perfect fresh air producer in the summer, so the microclimatic aspects are better to deal with. And before we designed anything, we had a criteria list for this building. What kind of aims, what kind of targets we want to address with this house. And that was a very important paper, 10 sentences, which helped us to develop that building further through the complete production and design process. We took a very careful look into synergies on site. So we did a chart where we looked into different user groups beside an office. What else can be done? We said we want to have a public restaurant. That organic food means that we want to show to people, we want to invite people. Then we said if we redo that site, we should also have most likely residential, we should have education. So we We convinced the client that we should do, together with the office structure, a strategy for a kindergarten, for schooling, that not doing an office and dealing again with these one single user group aspects, but have a complete strategy for all of the site. That was very important. We did a survey of geothermal potential, of sunlight potential. The psychromatic chart showed us the qualities or different difficulties when it comes to humidity. And then we had a very simple approach. We made a design process. We had a couple of models, and we tested the models with the easiest challenges. So how do we need to place the house on the site that we can deal maximum out of daylight conditions? So we had a perfect north-south orientation to have at least one north facade, which allows us to have only light but no solar gains. You know that, I mean, in Darmstadt, we have summer temperatures up to 40 degrees sometimes. So climate change already had an impact on that site. So we had to deal with solar hits in the summer, and especially when it comes to an office building, solar hits are the most important aspect you have to deal with. So, but we wanted to have a daylight-driven office, not only to reduce the consumption of electricity, but we believe it's important for the well-being of people. You want to have a daylight accessible space. You want to be in connection to outside. Today it's a beautiful snowy day in Stuttgart. You like to look out. You want to see that. So we developed a daylight-driven structure. We had some classical strategies. We opened the roof to north to have direct daylight in the middle of the place. We made a huge kind of an envelope, or a huge spaces, deep blades, not the classical 13 meters wide office spaces. We said, no, we raise the house, we raise the levels to have deeper areas enlightened by daylight. So you see that on the in the lighting charts there on the left. But the extra height also helps us to have a higher air volume in the building, and the higher air volume is more stable. It doesn't react so directly with the cooling and heating issues on the summer day. So it makes the building more stable. And the reused air does have space above the people's head. So the extra height also helps to have better air qualities with less airspeed in the building. So then we said, this extra height helps us for a natural earth duct, earth chimney, natural ventilation. So what we do, we use the earth's soil. We have an earth duct underneath the building, and we suck in the fresh air in front of the western wall, and the fresh air is moved into the house on natural sources. So the chimney effect of this atrium brings in the fresh air from the forest into the inner space. So daylight, fresh air from the forest. Then we collect every centimeter of rainwater, and we do an open cistern on the southern side of the house, and the little lake in front of the house retreat and help the microclimatic aspects, so it cools down the environment. We bring in the green area as close as possible to the building, no sealed areas, in order to get rid of heat island effects in the city. Certainly we have on the roof solar cells, but that is only the last element. The first was everything what could be done passively, we did. We have the round-shaped building here on the north, that's the kindergarten. We used parts of the existing paved areas for parking. We reused all the concrete we found on the site also for remodeling topography, because we said we have now on a yearly basis, we have the rainwater issues, the 1,000 heavily rainwaters coming down. So the microclimate, the climate change matters, and rainwater, stormwater management became more and more important. So we remodeled the topography to protect the building against stormwater issues. So that was all passively. And then when it came to materialization, we looked into natural materials. So here you see the concrete on the bottom right side. You see the heavily areas we found there. We reused them. For carpet, certainly there are cradle-to-cradle products on the market. That was sure, we can use them. Wood, and then it came to loam, to earth. How can we build a house out of loam again? Because in one of the strategy aspects, it was also clear that we don't want to do a classical office building with all these layered structures. So the left section shows you how a classical office is done. You have the concrete levels, you have the slabs, you have a raised ceiling, you have a raised floor, you have the construction of the facade, you have the insulation, you have the outdoor claddings. Lots of these elements are technically driven and not only absolutely needed. If you reconsider everything, it would be, in terms of durability, it would make much more sense to build simple, to give a bit more volume, to have materials which are actively when it comes to thermal mass. Here in Germany, Norway is a bit different, but here in Germany, we want to have some cooling aspects in summer. And what is technically needed, as I said, is then attached. So lighting is not part of the raised ceiling. It could be a stand light, could be something which you attach on the table or something. No raised floor. Cabling should be open, easily to access. That the superstructure, the house itself, is as simple as possible. So that was the strategy. And then we searched for materials we can use and we can done this kind of strategy with. And we did this typical life cycle analysis. Stones, concrete, wood. And it came up, we sliced the house and we calculated it with different materials to check in the design process what might be the best composition of what kind of materials can we embed. This is certainly some more than a typical architectural office is doing, but we had a good connection. I'm also a professor at the UPenn, and we had a connection with the Technical University in Munich. So we had a partner who helped us to deal with these kind of measurements. And we came up with, it would make sense to make a rammed earth facade. So many qualities we can see in that. First is, we found the earth everywhere, literally. Beside Darmstadt, we had a bit of an aspect there because Darmstadt, the place itself, it's a sandy kind of area, so we had to bring in the loam and the clay from 100 kilometers distance, and now I'm convinced about that. The transportation is so important, because when we started with that building, I wasn't aware how much embedded energy is in the transportation. So we brought in the material from Westerwald, the lava gravel from the Eifel region, but also some earth excavated from a tunnel project here in Stuttgart 21. We redo here the transportation, the train station new, and we reused the excavated material in Darmstadt. When we started with that, I was not an expert in rammed earth or earth construction, so I teamed up with Martin Rauch. You may have heard of him, and because what we also realized that we want to show people that this material is not anymore in the eco-niche. You know what I mean? So it does have so many good aspects. It's a regulator for humidity. It's the only element which have the same speed of getting rid of water and taking in water, that it always keeps, there is no algal, no mossy growth occurs on the surface. You don't have to have any cleaning works on the facade done with earth. It's such a stable, durable product, and it's completely natural. And the excellent properties in terms of humidity regulation, thermal storage, and the building preserve its value over a long period. So with all these elements ahead, we had to deal with the client's concerns about erosion. And then the other aspect, since we've thrown out raised floors, raised ceilings, we said, okay, we need to have a source for heating finally, because we realized that with our building strategy, we can easily get rid of overheating loads in the summer, but it cools down in the winter too much. So, and then we tried to engineer that facade. We said, why isn't it possible to think of a rammed earth facade together with the heating, a geothermal heating system? So because a radiant heating is the best heating you can get. It would be perfect to have that in that wall element, because it is then in face-to-face to the people. And that was quite challenging. And we worked over a year with certain mock-ups to find the right kind of insulation material, because we had to deal with this rammed earth facade of a new value. We wanted to reach up to the 3.5 kilowatt per square meter and year. At the beginning, we thought we can use, I don't have the English term for that, Dinkelspelzen, where my hand is in. We wanted to use a natural grain, but it didn't work out. We realized in the mock-up that the moisture value of this grain isn't good enough. So we finally ended with the insulation material of foam glass, a recycled product. We produced the rammed earth facade on site. So it was also a challenge due to the limited of building costs. So the building were not allowed to exceed a maximum cost value of 2,000 euro per square meter, which is low for such kind of an office building in the Frankfurt region. I don't know what kind of building costs you have in Norway, but it was a challenge. So you see here how the foamwork works. So you can see that the building itself is composed out of an insulated core. So it's 17 centimeters of this foam glass gravel. Then the outer rammed earth layer is 38 centimeters thick, and the inner is 14 centimeters thick. You see the little cabling coming out of this wood formwork? That is a water piping system we rammed in that inner kind of rammed earth facade. So, and then all of these were walls. One wall brick is 1 meter high, 3.5 meters wide, and these 70 centimeters thick. Needed to be dried out then for a couple of weeks. So, and that was a coincidence here on site. We had these former tank halls where they a kind of a workshop area for the military tanks. So we reused them for drying out and for production of the rammed earth stone elements. You see here how the glass gravel or is coming out of the middle. You see an end piece on the left side, and you see the truss line lines. Every 30 centimeter and 60 centimeter over the length of the wall, and at the corner every 30 centimeter. There are horizontal erosion barriers. This is clay and truss line, and they were integrated in the rammed earth facade. And what they do, they to stir the surface aeration of rammed earth. So it's a little bit like the river engineering works. They diminish the power of the water flow. So they minimizing the erosion. Now the building is there on site since 2.5 years, so it works brilliantly. It works quite well. We had some really stormy days, and we see that the erosion is perfect. But you have to deal that at the ground. You need to have a plinth. You need to have a foundation. So that piece of concrete where the first brick is located on is needed against direct erosion from the ground. So you need to have water protection aspects from the ground level. Here you can see in the construction process, you see on the right side, the section shows you a bit the way it is constructed. And on the left side, you can see how it is then modulated. At site, you see the piping system coming out for the radiant heating and cooling. Then the aluminium strip shows where the window needs to be attached. Building under construction. I have to speed up a bit, running out of time. You see here the performance of the building in and out. And as I said, the emotional aspect, beside all the extra qualities, the durability, the algal and mossy the health aspects of the building, the excellent properties in terms of humidity regulation, thermal storage and everything. But the emotional aspect for the people were from the very first day important. We have the building on survey, on monitoring since 2 years. And there you see at the very end, I am soon finished. You see in the first chart left temperature wings, summer. You see here sometimes up to 40 degrees on a summer day. The gray bar shows you the typical comfort as zone for an office building, and you see how good the loam and rammed earth facade works. You see sometimes the blue lines running out of this comfort zone. That was in the first year because we realized that the people didn't treat it insulation shading issues quite properly. But you can easily see in these charts how good the rammed earth facade deals with when it comes to temperature, but even better when it comes to moisture and humidity. And that is the right chart, where it's also without any technical supportment, the rammed earth easily balances out the humidity in the building and provides a perfect air quality. So, overdone a bit, that's the inside view. So it doesn't mean that everything is close and little. It's a big building, it's a big room, it's very open, it's inviting. But the rammed earth facade were absolutely plus for that building, and hopefully it's a kind of a breakthrough for this material here in Germany. Thank you very much for your attention.